Take a look at this simulation showing a robotic hand executing a physical transaction. Today, we interact with large language models, which are AI systems trained on massive amounts of text to predict and generate human-like written responses. But by 2026, the technology transitions from answering text prompts to taking physical and digital actions. This upcoming phase is known as Agentic AI. It is a system capable of autonomously navigating websites, verifying active inventory, and executing secure financial transactions on behalf of a user. Instead of typing a search query to browse options, a user will issue a single command, like buy a green leather bag for my sister's birthday, and the AI agent will locate the exact item, add it to a cart, input the payment details, and complete the checkout process entirely on its own. This shifts the role of search engines from passive information retrieval systems, where the user does the heavy lifting, into active task execution engines. Businesses that fail to prepare their digital infrastructure for autonomous execution will be invisible to this next generation of search. The immediate problem for e-commerce owners is that AI agents do not process visual interfaces. They do not see high-resolution images, brand colors, or the carefully designed layout aesthetics of a standard storefront. Traditional tactics, like stuffing a page with keywords, also fail here. An AI agent is attempting to execute a precise, deterministic task, like completing a secure purchase, rather than just summarize a page's content for a reader. Adapting to this requires generative engine optimization, or GEO. GEO is the technical framework used for translating visual storefronts into highly structured, machine-readable environments. To deploy GEO effectively, a website requires strict entity mapping, structured back-end markup, and flawless site architecture. Building a beautiful website for human buyers is no longer enough. The underlying architecture must explicitly instruct the machine on exactly what it is looking at. Consider what happens when an AI crawler encounters a jewelry business named Rebel Designs, but finds the web populated with companies sharing similar keywords, like Rebel Marketing or Rebel Design Collective. This animated diagram illustrates the result. The semantic overlap creates an identity crisis for the crawler. It becomes tangled in conflicting data, unable to distinguish the e-commerce store from an unrelated interior design firm. When faced with conflicting entities, the AI agent abandons the task execution entirely. The risk of making a critical purchasing error with a user's credit card is simply too high. To resolve these semantic conflicts, search engines rely on the EEAT framework. EEAT stands for Experience, Expertise, Authoritativeness, and Trustworthiness, which acts as the baseline criteria for evaluating a site's credibility. To establish this necessary authority, the business must be strictly defined as a distinct node within the search engine's broader knowledge graph. Defining these nodes requires mapping the exact, undeniable relationships between the business entity and its founders and the physical products it sells. Without explicit entity disambiguation, an AI agent will never trust a site enough to risk executing a financial transaction on it. You cannot define a business node or establish authority simply by writing paragraph text on an About Us page. Instead, developers use JSON-LD schema markup. JSON-LD is a precise programming language used to feed deterministic, undeniable definitions directly to search engines. As we see in this diagram, this markup lives exclusively in the site's backend. It is entirely invisible to human users, but it functions as a direct architectural blueprint for AI agents. Specific lines in this code map directly to exact entity attributes. The machine reads defined fields for the business's industry category, its corporate location, and its founder's identity. This structured data allows a large language model to immediately understand context without having to guess based on adjacent keywords found on the front end. This immediate contextual understanding speeds up the crawler's processing time, which significantly increases the likelihood of a successful task execution. JSON-LD schema acts as the foundational infrastructure required to turn a static, passive web page into an active AI executable database. Beyond back-end data structure, we also have to evaluate the physical URL pathways an AI agent must travel to locate a specific product. This reveals a major flaw in the default behavior of modern CMS platforms. A CMS, or content management system, is the software used to build and manage digital storefronts, like Shopify, and they dynamically categorize inventory. Look at this animation showing what happens when you place a single product into a collection. The platform dynamically generates a completely new, unique URL for that exact same physical item. An AI agent or search crawler views each of these distinct URLs not as a variation of one item, but as a completely separate competing page. This unmanaged duplication forces identical product pages to actively compete against each other for the search engine's limited page authority. This self-competition dilutes the ranking power across the board, causing both versions of the product to drop out of search visibility entirely. A crawler trapped in this duplication loop will exhaust its allocated computational crawl budget and abandon the site before it ever indexes the new inventory. Even perfectly mapped entity data is completely useless if the site's fundamental URL architecture actively traps the agent trying to read it. Modifying the core routing logic of an enterprise-level CMS to prevent this duplication is often impossible or highly unstable for the average site owner. The precise architectural solution to permanently bypass the duplicate URL problem is the canonical tag. A canonical tag is a strict directive placed in the page header that explicitly identifies the single master record of a product. This animation illustrates how the tag functions. It instructs the AI agent to completely ignore all dynamically generated collection URLs. Consolidating these pathways funnels all page authority and trust signals back into one highly authoritative product node. This streamlined architecture ensures the AI agent can rapidly verify inventory and execute a task without ever encountering conflicting data. The immediate impact of this fix is a drastic reduction in the time it takes for bots to discover and index newly launched products. Canonicalization acts as the mandatory traffic control system that guarantees an AI agent reaches the checkout sequence instead of a dead end. Deploying schema and canonical tags on the backend does not instantly update the search engine's memory of the site. Relying on standard organic crawl schedules means a newly launched product might remain invisible to purchasing agents for weeks. This image shows Google Search Console, a service that lets owners monitor their site's search presence. To force an immediate architectural update, you use its URL inspection tool. You input a new product URL into the tool, overriding the passive wait time by executing the request indexing command. This specific action places the URL into a priority crawl queue. It ensures the newly mapped entity data is ingested and accessible within 24 hours. Maintaining visibility and revenue in an AI-driven environment requires proactive manual index forcing rather than passive observation. The technical stack required for the next era of search relies on strict EEAT entity mapping via JSON LD, secured by flawless canonicalization. This specific combination of technical fixes successfully transforms a passive visual storefront into an active, machine-readable database. This visualization of a server tunnel represents the incoming wave of autonomous data processing. With Agentic AI scheduled for wide deployment by 2026, crawler logic has already begun favoring sites that provide these deterministic blueprints. Websites that fail to provide these machine-readable directives will be bypassed and ignored by autonomous purchasing agents. Architecting a platform for machine execution ensures a brand remains accessible as the primary mode of search moves from human browsing to autonomous fulfillment.